Okay, this is the pre-calculus 1.3 through 1.5 test review, the practice test. Just want to kind of go over some answers and give you guys a chance to verify how everything was working out. So give you a bunch of functions to work with at the beginning here. Want to evaluate some things. So to start out, part A, find k of 3. So we're simply just going to be using k of x here, and we would just plug in 3. So k of 3 would be 3 minus 1 over 2. And again, that simplifies the 2 over 2, so we should have just got 1 for that. Okay, another one, part B, just again, just plugging in g of 39. So that's a little sloppy up there. It didn't print out very nice, but g of x is the square root of x plus 10. So this is going to be the square root of 39 plus 10. Okay, so the square root of 49, which we can reduce down to 7. Okay, part C, a little bit more involved now. Find 8 or f of h of negative 1. So again, I would always think of these as, that's the inside piece. H of negative 1 is going to be some number that we're going to be able to find out by plugging into h of x. And h of x says it's 2x minus 1. So if we find h of negative 1 first, and we will plug that answer, then it'll get plugged into f. So h of negative 1 is, again, using the rule up here, 2 times negative 1 minus 1. Right, so that should be negative 2 minus 1, which is negative 3. Okay, so we really need to find f of that now. Okay, because we just found out that that is really just negative 3. So we need f of negative 3, and the rule for f of anything is square the number and then add 3. So negative 3 squared should get you 9. When you add 3, we should get up to 12. So that's the answer for part C. Okay, for part F, or part D, I mean a subtraction, there's a couple ways to do that. We could do, probably the best way is just to figure out what is h minus f of x. So let's do h minus f. Right, so we're going to do 2x minus 1, and we're going to subtract x squared plus 3. Okay, and we just need to watch out and make sure that we actually subtract both of these things here. So it's really 2x minus 1 minus x squared, and then it's really a minus 3 here. Okay, so when we combine or get the like terms in the right order, we write the biggest exponent. So negative x squared, and there was a positive 2x, and then we can combine the minus 1 and the minus 3, okay, into being a minus 4. Okay, and that one they didn't give us a specific number to use, so we would just leave our answer that way. Part E, we want to find the inverse of j of x. So let's get another little piece of paper here. J of x, again, was given on the paper as 1 over x minus 1, and we want to find j inverse of x, j negative 1. So if you remember, we're going to just go ahead and switch the x's and the y's. Okay, so again, the original function is y equals 1 over x minus 1. If we go ahead and switch those, it will become x equals 1 over y minus 1. Okay, now we need to realize we need to solve this thing for y. Okay, so what I'm going to do there is multiply both sides by y minus 1. Okay, because the variable is kind of trapped in the denominator there. So what I'm going to do is get it out of there by multiplying both sides. Okay, so we're going to get y minus 1 times x equals 1. Okay, and then what we can do is, again, we're trying to get this y by itself right here. Right? So let's divide both sides by x. Let's get rid of that. Okay, and that would leave us at y minus 1 equals 1 over x. And then we simply just add the 1 to the other side. Okay, and we'll get our answer y equals 1 over x plus 1. Okay, and that's the inverse of j. Okay, part F. Now they want us to determine if two things are inverses of each other. So they're talking about, in this example, f and g. So is this thing the inverse of this thing? Okay, and you can probably look at it and tell that it doesn't seem like it would work. But just to prove something, we need to actually go through the steps. So let's do that. So to be an inverse, so our f of x and g of x inverses of each other. Really the best way to prove it is to look at when you use the composition of functions. Does that equal the other order? And they both have to get you back to x. They have to be exactly x, meaning that the second function will undo whatever the first one did, and it'll get you back with what you started with, which was x. Okay, so let's do this. Let's do one of them. Let's do f of g of x. And again, here were the functions. F of x was x squared plus 3. G of x was the square root of x plus 10. Okay, so if we wanted to do f of g of x, I want to do this one. Okay, what we're going to do again is take the inside function. Okay, we're going to take g of x, which is this guy here, and we are going to plug it in to f in place of its x. Okay, so it's going to look like this. It needs to be x squared, but x is now the highlighted portion, so it's really the square root of x plus 10 squared plus 3. Okay, so again, the highlighted piece right here, that is just something we had replaced x with. So it was that thing squared plus 3. And then we'll just go ahead and do a little algebra on that. When you have something under a square root and you square it, it just becomes the x plus 10. It just becomes what was underneath there. And then we had a plus 3 on the end. So this simplifies to x plus 13. Okay, that is not equal to just x. So we would say these are not inverses of each other. Okay, we don't even have to check the other way. Okay, because there's no way they both equal x if the first one doesn't equal x. Okay, and that would be a nice proof for that. Okay, number 2, they give you a couple graphs, and we need to state the domain and range, and then also write the equation of the graph shown. Okay, so this one looks like it's shaped like the exponential, okay, the e to the x, but it looks like it's shifted up a little bit. And if you notice on this one, it looks like as you're going out to the negative infinity, there's kind of like an asymptote at 3. And this graph will just continue out and get close to 3. So normally on the normal exponential, that thing is approaching 0. Okay, so that tells me there's some sort of vertical shift going on here. And we know it's an exponential function, so the equation would have to be e to the x. And again, everything was shifted vertically. So outside of the function, not part of the exponent, there's a plus 3 out there. Okay, and then as far as the domain and range, if we take a look at this thing, okay, it's just kind of going on forever, going on forever. So the domain, it's going through all real numbers. Okay, but the range, technically, again, remember, there's that horizontal asymptote there through 3. So it's never going to quite get there. So that it goes from 3 and it goes all the way up on the right side of the graph. But it never quite gets to 3, so we're going to use a parenthesis there. Okay. And again, that one had a vertical shift of a plus 3. Okay, in part B here, clearly a quadratic graph. It looks like it's centered. Instead of at the origin, it looks like it was shifted to the left 3. And it also looks like it's been flipped down over the x-axis. So we're going to have a negative on the outside for the reflection. To go left 3, we need a plus 3 inside the function. Okay, and when I say inside the function, I mean the function here is squaring something, so that plus 3 needs to be inside that. That gives you the horizontal shift. Okay, and then domain and range on this one. Again, the domain's all real numbers for quadratics. Okay, because this thing's going to continue to go through all the possible x values. It's going to the left and right through everything. But the range, this one, it does have a maximum value at the vertex up here at 0. So the range would be from negative infinity. Remember, always do the smaller number up to 0, and it does actually get to 0. It includes 0. Okay, so that would be your domain and range. Okay, then the other part was the graphing portion. So let me pull that up. I'll display some of the answers here. I think I can do a presentation view. Okay, so this was the first part. It was number 3 on your paper, but I had it number 2 on this for some reason. But what we need to do is state all transformations, so any shifts, reflections, sketch the graph of of the transformed function. Okay, so here's what the graph should look like. It's an absolute value graph, and with the -1 on the outside, that's letting us know that this is a vertical shift down 1 unit. Okay, that's the only transformation. Okay, number 3. Okay, again, this is the quadratic is the main family there. I see a negative on the outside, so that's a flip over the x-axis. I see a -1 inside the parentheses, so that's going to shift to the right one. And then a +3 is a vertical shift of 3. So we can see the vertex was usually at 0, 0. The two shifts move it over to 1, 3. And then, of course, we're flipped downward. Okay, number 4, radical function with a couple translations in there. There's a +2 inside the square root, so that's going to shift us to the left 2. And then, of course, the +3 on the outside will move it up 3. Okay, so this one, again, usually starts at the origin, but we had those shifts on there. Okay, and the final one, we have a vertical, it's technically shrinking because we're multiplying it by 1/2. Okay, so it's a vertical shrink. And then we do have a phase shift or a horizontal shift. That plus pi over 6 is going to shift us to the left pi over 6. Okay, and this one, it's going to be kind of tough to graph. You're going to have to rely on your calculator a little bit and get a table of values. And just kind of do your best for now. We'll get more detail on the trig graphs later on, but it should look something like that. Okay, and again, we had the vertical shrink factor of 1/2, and then horizontal shift. All right, and that should get you through the entire review. And the test should be very similar.